Alright, we are very welcome today again to this YouTube channel. Today we'll be taking a question on the ideal gas equation, the relationship between ideal gas equation and density. But before then, I have discovered that many of us watch and enjoy these videos without subscribing to the channel. Please, if you have not done that, you can do it now before we dive into the solutions of these questions. Alright, now let's continue. The question said, calculate the density of ammonia, NH3, in gram per liter at 0.989 atm and 55 degrees Celsius. Now, let's go to the solution, but before then, let's check our parameters. Now, when you look at the question said we should calculate the density. Now, that means our density is not given. So, it is the density we are looking for, and said of ammonia in gram per liter. So, it means the unit for our density must be in gram per liter. If it's not in gram per liter, then we must convert it to gram per liter. So it said at 0.98 atm. Now, this 0.98 atm is our pressure. Why? Because pressure is measured in atmospheric pressure. So our P is 0.98 and 55 degrees Celsius. 55 degrees Celsius is our temperature. Why? Because temperature is measured in degree Celsius by the unit. We know the parameters. Now, if you look at this, you will discover that we said this question is under the relationship between density and ideal gas. And in an ideal gas, you must be given the ideal gas constant. So in case you are not given, when you look at the parameters, the unit of your parameters, you will know the one to use. But here we'll be using the one that is 0.0821 atm dm cube per mole per Kelvin. Now, the molar mass of density of ammonia, the molar mass of ammonia NH3 is 17.03 gram per mole. Yes, this is how we get it. We said since nitrogen is 14 gram per mole and hydrogen is 1.01 gram per mole, or approximately 1 gram per mole. Now, how many nitrogen do we have there? 1. You said 1 times 14 will give us 14 plus 1.01 or 1.01 times 3 will give us 3.03, which is, when you sum this together, it will give you 17.03 gram per mole. Now, because of the unit of our ideal gas constant, let's convert our parameters to match the units to help us in getting our final answer. So when you look at your temperature is in degrees Celsius. Now let's convert it to Kelvin. Converting from degrees Celsius to Kelvin, you will add 273, which will give you 328 Kelvin. Now, when you look at the unit of our ideal gas constant, I said our final answer should be in gram per liter. Now, when you look at that, when you check our unit, you will discover that your molar mass is in gram per mole, and your temperature is in Kelvin, and your pressure is in atm. But dm cube is a unit for volume. Now, volume can also be measured in centimeter cube or meter cube or liter. Now, when you look at dm cube, decimeter cube, 1 decimeter cube is equals to 1 liter. that means 1 liter is equals to 1 decimeter cube. So where we see ATM in the unit of our ideal gas constant, we can replace with liter. So our new value and the unit for our ideal gas constant become R equals to 0.0821 atm liter per mole per Kelvin. Now, the relationship between density and ideal gas constant is given by density is equal to pressure times molar mass all over ideal gas constant times temperature. Now, it is the density that we are looking for. So we said density is equal to, we have all these parameters, we have find them already. So we said density is equals to the value of our pressure, which is 0.989, the unit atm, times our molar mass, which is 17.03 gram per mole, all over our ideal gas constant, which is 0.0821 atm liter per mole per Kelvin, times our temperature, which is 328 Kelvin. Now, when you look at this unit, and you look at what is at the numerator and what is at the denominator, you will discover that ATM can cancel ATM, and mole can cancel mole, because this is like 1 all over mole all over 1 all over mole. Now, when you look at that, since if you have 1 all over mole all over 1 all over mole, this is the same thing as we can mathematically write this as 1 all over mole divided by 1 all over mole. Now, let's take reciprocal. In taking reciprocal, we have 1 all over mole. In taking reciprocal, where this division sign is, we replace it, or it changes it to multiplication sign. Now, since it changes to multiplication sign, the denominator, that is the 1 all over mole of this side, it will become mole all over 1. Now, when you multiply this, 1 times mole all over mole times mole will give you mole all over mole. Mole divided by mole is equals to 1. So that's why we said mole can cancel mole. Now, when you look at this for Kelvin, you can apply the same thing for it. That is the same thing as 1 all over Kelvin all over. Yes, this is the same thing as Kelvin all over Kelvin. So is equals to 1. So you will be left, when you multiply the numerator, you will have 16.84, that is 0.989 times 17.03 will give you 16.84. All over, when you multiply the denominator, it will give you 26.93. The unit of the numerator is in gram, 16.84 gram all over 26.93 liter. And when you divide this, it will give you 0.625 gram per liter. This is our final answer, and that is what they asked us to calculate. That's the unit they asked us to leave our final answer.